we are connected to trees in many, many ways. Take a look at those trees that still have green in the leaves right now. That green is chlorophyll. That chlorophyll is the same molecule as the hemoglobin in your blood, except for one difference. That molecule of chlorophyll has an atom of magnesium at the center, and our hemoglobin has an atom of iron at the center. Magnesium, green, iron, red. They're the same molecule. We've co-evolved. That is why we have such a strong affinity for these trees. And it was 1985 when I wrote my first book. This is it, Wisconsin's Champion Trees. This is actually the second edition. It lists the largest trees in each species that have been submitted to the Department of Natural Resources. And there are some great stories. My dear friend, Wolfgang Hoffman, who was a photographer at the College of Agriculture and Life Science at the University of Wisconsin, did the photographs. And so we went all around the state to remeasure these trees and to photograph them so that we could put them into a form that everyone here could then put in their pocket and go out and hunt for new big trees to be able to enlarge our understanding and appreciation of all those big trees. And what happens when there's some global changes going on inside those trees? Well, you know, have you noticed that we've had higher temperatures? Have you noticed that maybe we're having some warm weather in February that you don't remember when you were a kid growing up having? So there are some definitely observable changes happening to the environment. Trees are having a hard time with that. So if we have a warm period during the winter, and the trees have this very sophisticated, very long evolved ability to take the water that's inside each of those cells and let that water then leave the cell and go to that outside area, outside the cells, so that when water freezes, we know that it expands. The expansion will happen not inside the cell wall, but it's going to burst the cell wall, but be able to freeze normally out there, the cell stays intact. But what happens when things warm up and the tree is tricked to think that maybe it's an early spring and the water goes back in that cell and then quickly that night it refreezes? Well, same thing that happens to your carrot when you stick it in the freezer. It looks fine until you take it out and all of a sudden it's like a whip. So same thing happens to those individual cells. When that water goes back inside in mid-February, the tree gets tricked, the cell walls rupture as it expands, and they have damage, cold damage, the next spring that they have to deal with. Trees are able to deal with wounds quite nicely. If they have an area of wounding, they lay down barriers and protective walls. They're able to replace many of the cell pieces that are lost during those processes. It's that fact of the remarkable dynamic nature of trees that pulled me into this field of arboriculture, forestry, and urban forestry. I find it beyond fascinating. Trees have an important role in our lives, and they well deserve to have an important role in our lives because they're remarkable organisms, and they're companions on our planet Earth as we spin around together in this wonderful place called the universe.
What are the oldest redwood trees in California, and what are the oldest existing trees in Wisconsin?
Well, excellent question, and you'll have to read my book, I guess. So we better hand that forward to that gentleman, because there's a picture of the oldest tree that I know of in the state of Wisconsin to that. So the redwoods, Sequoia sempervirens and Sequoia giganteum, the coastal redwoods and the true redwoods out in California. And just, as you can tell, I can't, avoid asides here. Only 5% of that grouping of trees that existed pre-settlement still exists today. They were so quickly cut down, as you could imagine. Here we have a tree that is And the tallest one today is called Stratiferus. It's up in Humboldt County in Northern California, and it's 395 feet tall. 395 feet, 39-story tall building, you know, and nobody planted this tree. Nobody's watering this tree. It can only grow in very select areas where there is an adequate amount of fog rolling in. And why is that? These big, tall trees, which are the tallest in the world, are dependent upon the fog that comes in and leaves residual water up in the upper part of the tree, in that areas that can't have this normal capillary action pulling through. That longevity, the secret to longevity is not having optimum growing environments, but adversity. So if you think you have a tough life, be happy for that, because you're going to live a much longer life. The oldest tree in the state of Wisconsin is a bur oak, and it's growing in Waukesha County, and the oldest that I'm aware of. Now, there might be bigger ones, but it's listed in this book. We have a picture of it. And it's the most amazing tree to climb. You know, that's how I got in this business, love of trees and love of the physicality of climbing these trees. So I couldn't resist it. When Wolfgang and I were out taking the photographs, I said, God, I got to climb that tree. And so I ran over to it and was able to work up. And it had a collection of branches that created almost a mitt. It was like a glove. And I climbed up there and sat in that center and felt that I was just in the hand of God at that moment. It was just the most amazing feeling, just surrounded by that tree.
What are your thoughts on genetically altering our forest and the trees?
Well, you know, it's very interesting. There's a lot of work done on, you know, called genetically modified organisms, GMOs. In fact, 92% of all the corn planted is genetically modified. Upwards of, you know, 80% of all the cotton is GMO plants. Soybeans, it's closer to 95% genetically modified. But there's not a lot of work being done on genetically modifying trees. And why is that? Well, number one, it's not as profitable as it is for crops. You probably, you know, maybe can't make as many genetic improvements for the things that we would want, you know, maybe faster growing. And, you know, there's nothing wrong with the old Mendel form of propagating and natural selection. If you're taking a look at, like Gene Smalley did with the elm trees, he planted thousands of elm trees down at Arlington or in little pots in his greenhouses, and he waited to see what characteristics they had. He didn't have the ability then, like we do now, to do genetic sequencing as easily, but he was able to determine which ones, once he tried to infect each ones, had some sort of resistance, and he then developed disease-resistant American elms. So the same thing, if we have a collection of red pine that are growing better, that have higher quality wood for the purpose that we want, be it pulp, or maybe on white pines and other species better for mill logs, we can select those and we can clone those, you know, fairly easily. And we now have micropropagation, where they just take very small little parts and are able to put those in little test tubes, and suddenly you've got thousands of the same species. But I don't see it in the future, in the immediate future, that we're going to have genetically modified trees.
Thank you so much, Dr. Allison.